Alright, for problem number 1, we're looking as limit as x approaches 1 from the left. And because it's from the left, I'm going to use this one. So once again, I have 1 squared plus 2, which equals 3. For problem number 32, it's the same problem with the limit as x approaches 1 from the right. And so I'm going to plug it into the other one, which is 3 minus 1 squared, which is equal to 2. And then for 33, since the answer for 30, 31, and 32 were all not the same, the answer is the limit as x approaches 1 does not exist. Okay, problem number 34 is just a direct substitution. So we do the sine of 3 pi over 4. 3 pi over 4 is in the second quadrant, so the answer is going to be positive. Remembering our unit circle, we get the square root of 2 over 2. For problem number 35, we have another situation where they talk about that all of these three things are equal to L, which means that the limit as x approaches a of f of x has to be equal to L. For this next one, we're trying to do the tangent line slope for secant of x squared at x is equal to 3. So the first thing we need to do is we need to take the derivative. The derivative is the secant of x squared times the tangent of x squared times the derivative of the inside, which is 2x. So we got the secant of 3 squared, which is 9, the tangent of 3 squared, which is also 9, times 6. So when putting this in the calculator, I'm going to do the tangent of 9 times 6, and because we don't have a secant button, I'm going to do divided by the cosine of 3. Make sure that your calculator is in radians, or else you will get the wrong answer. The answer should have been 2.98. Alright, for the next one, we're talking about the absolute maximum on the interval from -1 to 1. So the first thing I'm going to do is I'm going to take the derivative, which is 2 minus 2x. And when I set that equal to 0, we get 2 equals 2x, and x equals 1, which is one of my endpoints anyway. So we need to plug in both of the endpoints. So we got 2 times 1, -1, minus -1 squared, and 2 times 1 minus 1 squared. So this turned out to be -3, and this turned out to be 1, and since we are looking for the absolute maximum is at the point 1, 1. Alright, so we're looking for where this is concave down, so we need two derivatives. So the first derivative is that one. The second derivative is 6x minus 6, which I said equal to 0. So 6x is equal to 6, x is equal to 1. So we go from -infinity to 1, and from 1 to infinity. And so I'll plug in 0 and I'll plug in 2 back into this part, which is a negative, then a positive. So this first part is concave down, which is what we're looking for, and the second part is concave up. Alright, for number 39, we are going to find the relative minimum value on the interval from -3 to 0, so we do 20x to the third minus 20x squared, and then we take x squared out, and we get 20, or actually we can take 20x squared out, and we get x minus 1. So we got x equals 0 and we got x equals 1. And so what I'm going to do is I'm going to plug in all of the numbers. Negative 3. I realized it said relative, but I think it meant absolute. So we'll put in, not 0. The endpoint, is 0. So those are the only ones we have to put into the equation, and then we will find it. So the first one, when I plugged in negative 3, I got 315. When I plugged in 0, I got 0. Since I'm looking for the minimum, the answer is 0. Last one, we're trying to find the critical numbers. So we take the derivative. 2/3 minus 1 is negative 1/3 times negative 6x. So 9 minus 3x squared goes into the denominator to the 1/3 power. This turns out to be negative 4x when I simplify 2/3 times negative 6x. When I set the numerator equal to 0, I get x equals 0. When I set the bottom equal to 0, I'm only really worried about what's inside the parenthesis. So we add 3x squared to the other side. X squared equals 3. X equals plus or minus the square root of 3. So there are 3 critical values, and all 3 of them are critical. We don't know if they're maxes or mins or neither, but the critical values are when the derivative is undefined or equal to 0.